Hi, my name is Dai Matsuzaka, and today we're going to do Chapter 5.3, Trigonometry. So, let's work with triangles again. Perfect. And we're going to call this theta. Okay, so we're just giving it a name, right? Theta is the name of this angle specifically. We're going to call this side the A, or adjacent side, because it's adjacent to this angle. We're going to call this O for opposite, because it's on the opposite side of the angle, the theta. And we're going to call this long side, as we have discussed before, the hypotenuse. So we'll just call that H. Then we have a following relation. So sine theta, sine as a function, outputs the ratio between the opposite over the hypotenuse. Cosine of theta, right, the function cosine, outputs the ratio adjacent over hypotenuse. And tangent outputs the output of opposite over adjacent. You can remember this as SOHCAHTOA, but basically this is something you just have to know and memorize, okay? Remember that the changes of the input, if you change the angle, right? For example, if you choose theta to be over here, then your opposite, adjacent, and hypotenuse change. Hypotenuse stays the same because there's only one hypotenuse on a triangle, but this opposite is now adjacent to this theta prime. So if you were to calculate sine theta prime, now this is a whole different thing. Now the ratio is actually, if you keep the labeling, it's actually because it's opposite over hypotenuse, and opposite in this case is the A, it'd be A over H. Now this actually leads us to the next part, where basically, if we have a triangle as follows, and we call this theta 1, this is theta 2, right? These two are called complementary angles of the right triangle because they're, across from each other. Now, what we know is that sine theta 1 is actually equal to cos theta 2, and sine theta 2 is equal to cos theta 1. What does that actually tell us? Well, let's just look at it in terms of ratios. What are they actually, right? So sine theta 1 is, if you remember, SOHCAHTOA, right? So opposite over hypotenuse. So with respect to this theta 1, our opposite side is here, and our hypotenuse is here. So let's just call this opposite 1 because, it's in respect to the theta 1. So then sine theta 1 is equal to opposite 1 over hypotenuse, which is just this base right here, this bottom base. Right, now what about cos theta 2? Well, cos theta 2, if you remember SOHCAHTOA, it's adjacent over hypotenuse. But what's adjacent with respect to theta 2? It's also the opposite one. It's right here. It's this bottom base. So this is, let me color this differently. I think it's the best way to approach this. So let me get the triangle theta 1, and I'm going to color theta 2 with the red. Theta 2. So we have, this is opposite 1 and H. We agreed that sine of theta 1 is equal to this opposite side over the hypotenuse. But with regards to cos theta 2, the adjacent side is also the same thing. It's right here. It's the same length as the opposite one. So cos of theta 2 is actually equivalent to adjacent 2 over H. But what do you realize is, well, the hypotenuse is obviously the same thing here. And is opposite 1 equal to adjacent 2? Yes, they are. It's literally the same side of the triangle. So this ratio is exactly the same thing. So you need to realize right here, right now, that the sine and cosine functions, and tangent as well, it's very dependent on which angle you're choosing to get your ratio. If you're choosing theta 1, then your opposite side is the bottom base. If you choose theta 2, your opposite is the one that is vertical. Your adjacent side is the one that is the base. So this actually explains sine theta 2 is equal to cos theta 1 as well, right? Well, what's cos theta 1? Well, theta 1 with regards to, let's just do theta 2 actually. So sine theta 2, it's, again, opposite over hypotenuse. But what's opposite with regards to theta 2? It's this side over here, the vertical side. Let's call this opposite 2. Let's cos theta 1. Well, cos theta 1, well, it's theta 1. So what's adjacent with respect to theta 1? Adjacent is exactly this one. So what do you have? Well, the opposite with regards to theta 2 is equal to the adjacent with respect to theta 1. So the ratio opposite to a1 over h is equal to opposite to over h, right? Because the hypotenuse is always the same. And we notice that the adjacent to respect to theta 1 is equal to opposite with respect to theta 2. Now, let the unit circles be centered at the origin with radius 1. So, say we have a circle with radius 1 and circles around. Okay. Then we have that sine theta is always, and theta is going to be some angle here. So this is theta, okay? Then sine theta is going to be, if you recall, it's opposite over hypotenuse. But what's opposite? Well, the opposite value is y. So sine theta is equal to y over, and what is the radius, right? That's the hypotenuse. So there you go, y over r. Well, r is equal to 1, so sine theta is just equal to y. What's cos theta? Well, cos theta is adjacent over hypotenuse. But what's hypotenuse? 1 again. So what is it? Well, it's going to be equal to the value x. And how about tan theta? Well, it's going to be equal to opposite over the adjacent. But what's opposite with regards to theta here? Well, it's going to be the outside value here, which is just y. So it's y over x. And there you go. You have a great formula for finding out what the radius, what the sine, cos, and tan is given a radius of 1. I will see you next time in Chapter 5.4, Angles and Arc Lengths.